Hello, my name is Frank Wu, and I'm joined with Justin Shu today, and we're going to be talking to you about compound interest. In this video, we will be deriving the normal compound interest formula along with the continuously compounded interest formula.
Hello, today I'll be doing a video on compound interest. Let's start with a simple problem first. Let's say you have $100 in the bank and the interest rate is 50%. You check on this account 1 year later, and how much money will you see? You'll see $150, as you can see from this equation. Let's say you check 2 years later. Then you'll see $225, as you can see from this equation again. So what's the more general form of this? You can see that will be 100 times 1.5 to the t is equal to a, where t is the amount of years you check later and a is the amount. You can go even more general by doing this. A is equal to p times 1 plus r to the t, where p is the original amount and r is the interest rate. And as same as before, t is the amount, the years, and a is the future amount. That's an example of compounding yearly, but what if you want to compound semi-annually or even every month? Let's start with a simple problem again. Let's say you still have $100 and the interest rate is still 50%. Let's say you compound semi-annually. What that means is that basically you'll compound half the interest rate 2 times a year. After 1 year, you'll see that you have $156.25. So what's the more general form of this? You can see that it will be 100 times parentheses 1 plus 0.5 over 2, which is the interest rate, to the 2t, which is equal to the future amount a. Going even more general, you'll see that it will be a is equal to the principal amount, which is original, plus 1 plus r over n, where r is the interest rate and n is the number of times you compound per year, to the nt. And that's it on compounding interest.
So, continuously compounded interest is a different type of interest where we compound an infinite number of times per year. So basically, when n is equal to infinity. So, for this type of compounding interest, we have a new formula, which you can derive from this formula, which is p times e to the rt power. So, e is a special constant. It's a irrational number, just like pi is. And so if we have an expression like this, 1 plus 1 over x to the x power, when x approaches infinity, the value of this equation, so say y approaches e, and e is about it's about 2.718. To help visualize this, I've made a graph on Desmos. Here it is. We can follow this point here in the labels to see what the y value is as the x increases. So the red here is this equation, 1 plus 1 over x to the x power, and this is just what an x when we have an x value, what the y value is. So you can see as it increases, the amount gets closer to 2.718. So now that we know what E is, we can derive the formula. So here I've written out all of what we know already. I've sorted all information out. So first, what we want to do is we want to make this something it looks something like this. So basically, first we're gonna put all over n as a denominator. We're gonna turn that into a denominator. So 1 over something. So we're gonna turn it into this. So now that we have this, we can make the exponent something like that too. So we have n over r over here. So we can turn that into this. So we have something like this. Now we can notice that if we come up with a little if we come up with a variable we're just gonna call it x, which is equal to n over r. We can replace it, and we have this. We know that n is approaching infinity, and r is a regular number. So, and infinity divided by any regular number is still infinity. So we know x is infinity. So we can replace this first. And we know that this value is equal to e. So we have p, e, r, t. So that is our formula.
That's it for our video on compound interest. Thanks for watching.